Assalamualaikum, ma'am. How are you, ma'am?
Walaikum assalam. Alhamdulillah. How are you?
Alhamdulillah, ma'am. Very good.
Good. Okay, let's start our today's lecture. We have discussed the strategies that we are using, our models that we have to use for the development of different software, and according to different situations, we can use different type of software methodologies. In today's lecture, we will discuss the three strategies that will be the strategies of RDA model, prototype model, and dynamic model that we can use to create any software. We will discuss their phases in the detail. First of all, we will discuss the prototype model. Prototype model means we have to generate or we have to create a dummy model, or we can say that we can create an animated model or a rough model for our software or our project, and we will present that model towards our customer. And if the customer have no issues with that model, we will continue towards the development phase, or we will go towards the construction phase. But if they demand any type of changes in that model, we have to make changes in the specific model, and then we will show that model towards our customer for their recommendations or for their comments. And if their comment will be positive, we will uh, create a software that is same like that model. So in this model, there are the chances of there are the more chances of user satisfaction as compared to the other models, as we are showing a dummy model in advance, and then our final copy of software will be as will be match same as the prototype model is. So in this model, the end product is first developed, tested, and refined as per customer feedback. We will do the repetition of amendments in the model till a final acceptance will be done by the user. We will update that model continuously until unless the customer is fully satisfied with the final result. Now we will discuss the phases are the stages of that prototype model. The customer feedback is used to develop or refine the prototype. We will collect the requirements of the user, and then we will create a dummy model according to the requirement. And then we will present that model for the testing by the customer, and then we again take the feedback from the customer, and then we will develop or refine the prototype. It is a continuous cycle, and there is no restriction. Either it takes four iterations, five iterations, 10 iterations. So it depends on our working, and it depends on the strong communication between the user and the developer. So we can easily generate a model in minimum stages, in minimum iteration, and we can go towards the development phase. So we will discuss these phases. First thing is that we have to define the vision. Vision means we have to understand what the actual problem is. As in all the models, we have to set a meeting with the customer. We have to take the demands from the customer. That can be a requirement gathering stage or a requirement understanding stage. We have to understand what is the demand of the customer, why they are demanding or they are creating that software, what is the reason behind that, what are their expectations from the output. So we have to understand the scope and the reason and the vision behind that project or the software. So at that point in the prototyping process, the developer needs to come with a primary vision for their product. If we can't understand the scope and the basic theme of that project, we will be unable to prepare a good model or a good dummy model for that. So this phase may include the sketches, but it can also work as a verbal description. Like we are communicating with our customer, we have to set a meeting, and in that meeting we can list down the requirements of the user, or we can make a sketch of that software or a project. So for our understanding and for our analyzation, because after that meeting we have to understand, or we have to conclude that which things are required for our working. We have to conclude or summarize that requirements are that features that we will be, our functionality that we will add in our software or models. So, for our better understanding, we will ask or answer these questions. We will ask these questions from the customer, and also we will discuss these questions along with our team members, and we will answer effectively these questions for our better understanding. What problem does it solve? Like either they want to facilitate specific areas customer, or they have to give an app for the the better availability of their services, or they want to attract the new users, or for which purpose they are going to develop that application or that software. We have to understand the reason. Then who is the key market? Like either that is a market related to the services, like that can be a internet based services, or that can be any type of other production services. So we have to check in which market we are going to produce that thing, because as we know there is a competition inside the market. So we have to compete over competitors. So we have to check the market, and we have to check the strategies other competitors are using, and we have to throw a strategy or a thing that is different from our competitors. So we have to understand the market and the requirements of the market. What other options are available? Like instead of going to the online application or online admission system or online purchasing or e-commerce, what can be an other option? We can do the services that can be on steps, on their doorstep, or we can make over different outlets in every populated area. So we have to understand, is there any option, other option available, and either the other option is more suitable, or our option is more suitable. What is the estimated price point? Like how much budget it will consume for their construction of that software. Sometimes when we are constructing any software, the output will not be enough to complete the cost. Our revenue cannot be meet at the end. So we have to estimate the cost, and either that software is within the budget of the company or the customer or not. Then we have to understand what are the material and labor needs for that software. Like we have to use the servers, we have to use the multimedia computers, we have to use different type of skilled persons. Like we have to hire different coders. We have to need a project manager for that. We have to use different labors for their production. So we have to check which type of team is needed to complete that project, and which tools are needed. Either these tools we have to purchase these tools from the market, or these tools are available free of cost. So we have to understand which tools are needed, which tools will be better for the completion of that project. So by answering these questions, we can solve the problem in more effective way. That by answering these questions, we will be able to check the scenario, or we can lay out a platform. By following these steps or these things, we can construct our prototype in more effective way. So it will give clue to the design that will be useful, and if its demand will be able to justify the cost of creation. This way The creator can determine if the prototype typing is even necessary or if they should reconsider their vision. If that is including too much cost, and like a company has only 20 or 30 persons and they are trying to launch their online services. So sometimes it is not the right time to give an online application to the minimum users. We have to facilitate that users by using another option, and then we will increase the users in number of hundreds. Then we will go towards the online application. So if we think that they have enough budget, and if they are spending their budget and it will give the enough profit or enough benefit to the company, then we will suggest them to go towards the designing or go towards the creation of that software. Otherwise they have to reconsider that either they have to build that software or not. Now when we are sure about we are going to design the prototype, then we have to focus on the key features, the main features of. We are not focusing, like we can say that we will focus only the major functionality of that software. Like one common mistake of creator is trying to make their prototype identical to the end product. We are only giving a dummy model. Like we can say that we are only giving, we will not focus on the interface, we will not focus on the color scheming, and we are not focusing on different deep issues inside that. So we have to only focus on the major things or major functions. Major functionality will be focused in the prototype, as the prototype is same as the final product, but the final product will be a defined version of a prototype. We will add different functionalities in the final product at the last, but in the start we are only showing the major functionalities of our software. While this is useful when the prototype is for demonstrating value to investor, it's not necessary for most other needs. Sometimes the professionals try to make it more attractive. For that reason, they are trying to make a identical prototype as the end product, but it may take a lot of cost, and sometimes it may take a lot of time. So it might be useful for the presentation purposes, but in some areas or for some other reasons, it's not a good option to create a prototype that is really identical to the end product. The creator should single out one or two key features for their product to focus on in their prototype. Like if we are creating a application for the banking sector, we have to put one or two things, like we have to put the cash transactions, or we can focus on the billing by using that application. Other features can be added time to time. So in the prototype application or in prototype module, we can only mention how that application can be used for the cash transaction and for the billing purpose. So less critical issues like overall cosmetic look of the product or optional features are not necessary unless they are the sole reason for prototyping. Like if somehow we are creating a website for any company, their work is for interior decoration or for the things that relates to the um, interfaces are graphics. So we have to focus on the interfaces and the cosmetic look, because that is the main theme of that software or that website. If that is not a main reason or not a concerned area, we only need the functionality. Like I have given you the example of banking sector, so there is no need to focus on the cosmetic look. We will only focus on the functionality of our software. Now produce. When we are sure about for which key features we have to make a prototype, we will go towards the production phase. So the actual building of prototype is the lengthiest part of the process. As I told you, there is no limitation of iteration that can be completed in two iteration, three iteration, four iteration. It might take 12 to 15 iterations. So that is a more complicated and lengthier part of the processing that creator has to do. Some standard prototyping methods to consider includes 3D printing. This is a great option when a creator has a clear vision and wants a fast way to test its efficiency and function. We are only giving a 3D model that is look like model, but that is not a working model. We can only say that that is a 3D printing model, and we are only giving the outlook of that model towards our customer. However, it may not be ideal for a situation where highly detailed near perfect model is required, like if we are going towards a complex project or a new project, it will not be a good idea. But if we are working on the older services or the common services, that can be a good idea for less costly modeling. Now, CNC machining. It's great when the creator needs a highly detailed model. It's process that eliminates potential human error as much of the creation is automated and machine controlled. So we generate a model that is controlled by the machine. So that can be good as it is like a working model of our software. So when we will present a working model toward our customer, it can easily sort out the errors in that and pinpoint the areas that needed to be focused in the actual product. Power bed fusion. This is the process specially designed, for metal or aluminum materials with the high melting points. If the prototype must be in these materials, it's a ideal option. We have to create an animated model we're not actually doing in the actual mold making and casting. This process allows a lot of flexibility and is ideal for building custom parts and designs without the need of computer input. Like we have to do a machine work, we don't need to involve a computer input, we can do that. In some cases, a few different methods are employed in developing the prototype. For the best result, the choice will generally depend on the materials used, timeline, and the budget. We have to check what is our need, and according to that we will produce a prototype. Now we have developed a prototype. Now we will go and we present that prototype to our customer, and then they will check either that is according to their demand or not. If that is according to the demand, it will be okay, and we will go towards the next stage. Before presentation of that, we will do the testing at our own stage. So we have to check, as we have to we have communicated with our customer at the initial stage. Now we know the demand of our customer, and we will check our model as it according to the customer demand or not. So after rolling out the initial prototype, the creator will want to evaluate, consider, update options, and seek out ways to improve the overall process. If there is any error occurred, we will refine our prototype, and then we will present that model towards our customer. So at that phase, the testing will be done by the creator of that prototype. This may require a few simple tweaks, or it could involve the scrapping our whole initial design and starting over from step one. Sometimes the prototype is not good enough, so we have to completely change it. In any case, testing and refining should occur multiple times to ensure the prototype is ready to be disclosed to the stakeholders, because that is the idea we are going to present in front of our stakeholder or the customer. And if they are not satisfied and we have invested over cost in the prototype, that cost will be wasted. So we have to make a attractive prototype to satisfy our customers. So before presenting that prototype in front of the customer or stakeholder, we have to test and refine that prototype properly. Then in next phase, we have to present that prototype towards our stakeholder. So we will explain all the functionality and the purpose of that prototype to the stakeholder. It may include creating multiple models for the testing among the consumers. Like we will create the multiple prototypes so they can easily select one of them, sending the design in for patenting or showing it to the potential investors. The presentation stage will both help estimate interest and guide manufacturing methods, whether the need is for the simple short run or if more mass production is necessary. We can judge how much time is needed for the final prototype. So we have to communicate with the stakeholder in the presentation phase, so we can easily understand these things. When our prototype is ready, then we will go towards the designing phase. We will design our software according to that prototype. Then we will go towards the testing, and then we will go towards the deployment and refinement. But before going towards the testing, we will be sure about the success of our project. So that's why we can use that type of prototype modeling. Now, the plus points of over that model is that the customer get to see the partial product early in the life cycle. So they can see the dummy model, so they will be sure about the working model of that project. This ensures a greater level of customer satisfaction and comfort, as there are the less chances in the and less chances of failure in the end. New requirements can be easily accommodated as there is a scope for the refinement. As we have, there is no time limitation or iteration limitation in refinement, so we can easily adjust the new requirements that are demanded by the customer. Missing functionality can be easily figured out as it is a working model, and when we see the working model in front of us, we can easily figure out which functionality is not available inside that software. Errors can be detected much easier, thereby saving a lot of efforts and cost, as the prototype is a tested model. So we can easily understand what errors are inside that model, and we can easily correct that models. And when we will go towards the design phase, it will be easy for us, and there will be less effort to do that work. Besides enhancing the quality of the software, it also will increase the quality of the software, because when there are the less errors and we will create a project according to the demand of our customer, so we can say that we are focusing on the qualitative work. The developed prototype can be reused by the developer for more complicated projects. Sometimes the other company can demand the project that is relevant to the functionality that we have delivered in the earliest time. So we can reuse that model, and we can make a little bit modification in that model, and we can present that model towards any other organization. So it will help us in the future. Now, what are the weaknesses or the weak areas? As it is costly because it takes a lot of time as well as money. And sometimes when we are generating the model, it will not be approved by the customer, and we will not be able to get any payback from our customer. So sometimes it is very time consuming as well as the costly model. There may be too much variation in the requirements each time the prototype is evaluated by the customer. As the customer has an option to make modification in the prototype, so sometimes they can add too much variations, or different things can be added by the customer with time, as we have much flexibility in that model. It is very difficult for the customer, so the developers, to accommodate all the changes demanded by the customer, as we are creating a working model and then we have to go towards the designing. And if we are taking a lot of time to generate our prototype, we cannot take any other project from any other organization. So it will be very difficult to facilitate each and every demand of the customer. So it will be sometime become very difficult to accommodate all changes that are demanded by the customer with time. This is uncertainty in determining the number of iteration that would be required before the prototype is finally accepted by the customer. As I told you in the previous slide, there is no limitation in how much times or in how much refinements the customer will be fully satisfied, and in the last we and the customer might be not agreed with us and they can leave, and they will not sign any contract to work with our organization or with our software house. So in the last, sometime it will not be a good experience of the developer as well as the customer. So there is no time limit or there is no limit on the number of iteration when we are refining any prototype. After seeing any early prototype, the customer sometimes demand the actual product to be delivered soon. As we are only creating a dummy model, and as the customer is not well familiar with the development phase or with the development timelines, so sometimes it give us a little bit time for the completion of the project. That is very difficult for us, as it put a lot of workload on the team and a lot of stress on the team. The customer might lose interest in the product if he or she is not satisfied with the initial prototype. Sometimes they, in the start, they can't understand it is not an actual model, it's only a dummy model, and they lose interest inside that prototype and they will not be satisfied. Now, where we can use that type of model, that prototyping model should be used when the requirements of the project is not clearly. We have vague set of requirements or are not sure about the requirements. We can use that type of model. It can also be used if the requirements are changing quickly, like we are making a thing that is rapidly changing, like that can be thing that is related to the artificial intelligence or the new technology that we are using. So for that purpose we can use that prototype model. This model can be successfully used for developing user interfaces and systems with the complex algorithms and the interfaces, where there are a variety of interfaces are already available inside the market. Now we have to making a unique interface is a challenging job. So we have in such situations we can use that type of model. Now the next is feature driven model. In feature-driven models, that is also a type of agile methodology for developing a software that is centric, like we have to uh, outline the whole project at the start. We can say that that is a center of our model. Then we create that iterations or that phases in iterative manner, like from the whole project we will divide that project into different chunks or into different modules, and then we will create that in the iteration method, and the incremental way we can make the incrementation refinements in that created iteration. So that is not only iterative model, that is also an incremental model. Feature-driven model allow team to update the project regularly and identify the errors quickly. As we are creating about the features, so we can update the errors, and we are dividing our project into small chunks, and we will divide our project into the chunks that can be completed in 2 weeks. We are only making a set of functionality that can that we can complete in 2 weeks. So that is a small part of our project. So identifying the errors from that part of the project is easy as compared to identifying the errors from the a lot of work. So it is easily to identify the errors and we can easily complete that project. Now, that is the layout that we are going to follow. The first thing is that we have to create a overall model. We have to understand what the our project is. Then we will create a overall model. Like we can list down the different modules. Like if we are going to generate software for any university or for any bank, we will list down all the functionality. Like for banking sector, we have to list down, we have to add the cash transaction, we have to add the billing, we have to add the phone packages, and different other packages can be included. How we can order the checkbooks, how we can order the ATMs, how the customer can change the password, how we can maintain their e-statements. So these are the overall functionalities that we will list down in the first stage. After that, in each module, like in login, which things are required, we will make a features list. Like we will name module the login system, and in that we will list down all the features. Like in login, we have to generate a username, we have to generate a password, then we have to check their account number, their ATM number. These things will be saved by the user. So we will check the features list of each module. Then we will plan how we can make assets from that features. Like we have created the 100 features for our project, then we have to combine two or three same features in a set. So now we have to make the sets from that list. Then we will design that sets. So we are saying that we can design by the feature, and in the last we will build by the feature. In the designing phase, we are creating the layout for that features, and in the building stage, we will go towards the coding. Now we will discuss the phases of feature driven model. The first thing is that we have to create the overall model. We have to outline an initial domain object model in which we have to list down all the modules and all the functionality that we are going to offer in that software. Teams of developer and domain experts each define a model that reflects their shared understanding of the important objects in the new system. So different persons will generate their model, and in the last they will discuss which things must be, the same things will be included in the final model. And according to their suggestions and according to their communication, they can check the list of the functionality and can pinpoint the important objects in the new system. The chief architect supports and guides them in this work. When they are communicating with each other, the team leader or the chief architect can support them to choose the important objects of that project. When these are done, all models are reviewed to come up with the initial model for the next step. The team leader will check all the model and can combine these models to in a one single model. This can be one of the models are one that is a composite of one or more of the individual teams model. So that can be a final model of any team, or we can combine two or three different models of the different teams. So we have to choose one model, or we have to create one model from the multiple model in the last. So the input will be the different models that are generated by different teams, and the output will be the final project model that on which we are going to work. Now we have generated the actual model for that. Now we will go towards the feature list. In the feature list, we will list down all the do's that we will do in any module or in any domain. All the functionality the products need to offer. We will list down all these functionalities. To do this, you split the domain model into the subdomains. Like I told you that we have to generate a banking application that is over main domain, and then we will create these domains into subdomains, like the login system, the billing system, the transaction system, the loan system, and the ATM systems. So different type of subdomains can be generated by that. For each subdomain, then again we will list down the feature list of that. Like for login system, we will list down what do's we will do in that. You will require to product to support your customer in that business function. So for each subdomain, we have to list down all the features. Features are closely related, are often grouped into the feature set. Then as I told you, then we have a list of features. We will combine the likely features in a set, and then we will going for the development of that features. A feature set can also be a feature broken down into smaller one, because it would otherwise take more than 2 weeks to complete. Sometimes like a login system or a transaction system might be complicated system, so we can divide over features into small chunks also. So a single feature can be completed in 2 or 3 phases, as we have set that we have to complete all the features set are features in 2 weeks. If any feature is taking the time more than 2 weeks, we will divide that feature into small pieces. Now we have to plan by the feature, as we have generated or created the sets of that feature. Now we will give numbering to that feature, like we have to make a sequence of that feature sets, which feature set will be done at the start, which feature list will be do towards the next. So we have to make a sequence from that sets. The third step is where you plan the order in which the developed features and feature sets. Factors to consider are how we can give the sequence to that features. We have to consider that which features customers need most urgently, like the basic application must be used for the transaction of the money, so we will develop that at the start. Which features will deliver the most value soonest, like it will give a working model to our banking application if we are giving them the online billing, or we are giving them the transaction option. So we can say that after the transaction option, the billing will add the feasibility for our customer. So we will add that feature set in the next slot. Development time estimates, you don't want to leave the biggest features for the last. So we will do the small task at the start, because we are delivering different working model. We will do the biggest task at the start, so in the end we can easily deliver the and if there is any time and complications occurs, the small task can be completed in less time. After making a sets of the features and we have given the sequence to that sets, then we will go towards the planning. Now we have to assign the team members who are suitable for the completion of that feature set. So at the third step, we have planned an order in which we have developed the features or the feature sets, which and it will be developed according to the features the customer needed urgently, which features will be delivered the value to soonest to our project. We will give higher priority to that, and we will choose the biggest features at the start. We will see our features as the availability of our developers and skill persons, and then we will check the workload. Either a team member is busy in another project, and we are giving extra burden on that, so we have to check that the result is a ordered list of everything you need to implement. So in planning phase, we will make a ordered list of our features. Now, after planning, we will go towards the construction phase. In the construction phase, we will start the designing and building. In the designing, we are creating a layout, that might be a flowchart, that might be a algorithm, or that might be a sketch of our software or project. So by using that step, you work through the feature list on the feature by feature basis. We have to design that things are sketches by or using these features. Now work proceeds in 2 week cycles. We have to complete all that work in 2 cycles only, our iterations, and this fundamentally iterative and incremental. And after completion of one thing, we will go towards the next feature, so that is also give the increments, that is a layout of incremental phases. So we are updating over work. The strict 2 week cycle is why FDD wants you to break up features to fit that. So that's why we are dividing over feature in the length that can be completed in 2 weeks. So it's okay to form a reform teams with the requirements of the features you will build next in mind. So we can change the team members in the next feature set. Now we will design by using these feature. In designing phase we are going towards the coding. Now the developers and the domain expert help the chief architect and chief programmer as needed, as they have made the sketch, so they can help the programmer how in programming and in coding working on these specific design. Knowledge about the product increase the informs and changes needed to initial domain object model. So if there is any changing required, the persons who have done work on the designing, they can inform the programmer and they can make the changes in each iteration in each work set on which we are working. At the end of the design phase, a review by the entire team ensures that the overlaps are in identified and all the team members are aware of all overall model and design and stays within the original product concept. So in the end we will check all over working and we will make meeting. In that we will discuss over work, and if there is any flaws there, so we will make the improvements in the end. Now build by the feature, each feature team then start working, and some go towards the development phase, some go towards the coding phase, some will develop the interfaces for that. So now we will each team member will do their work according to their turn, and they will design a working software. Then after designing of the software, it will go towards the testing phase. Like we have to test either all the requirements are according to our input or not, and we have to check the working is according and the output for the specific inputs are good or good enough or not. And then in the last we have to gather the feedback from the domain experts, like from the team leaders or the managers, to verify that the feature works as intended. When all thing will be okay, they will integrate their work. Like if we are on the third set, then we will add that integrate that third set to with the working of first two sets. So they can be in the working phase by each and every set or module. So we have to integrate our work in the last. Now what are the advantages of using that model? It will give a very good understanding of the project scope and the context, because we have all the functionality list and in which functionality which features are required. Requires fewer meetings, as we have decided all the things in the start, so there is no need to do the meetings after a week or at on daily basis. So it demands only the few meetings. It FDD, the client is the end user. We are handing over our project to the user so they can check the project according to their needs. It works well with the large scale, long term, or ongoing projects that needs a lot of functionality. So we will add the functionality with time. The five well defined steps make it easier for new team members or new hires to come up to speed on the project very quickly. So as we have decided the work that can be completed in 2 weeks, so the team members will feel it easy. Break feature set into the smaller chunks and regular iterative release, which make it easier to track and fix the coding error. Less work, maybe include less errors, and rectifying these errors and checking these errors are also easy. It will reduce the risk of failure and allows you to make a quick turn out to meet your client's need, as we are delivering over set one by one. So it will um, uh, giving turnout very quickly. Where we can use the weak areas, it is not ideal for the smaller projects, as we will divide over larger projects in the features, and it will not be suitable for the smaller project and does not work for the project where there is only one developer, because we have different feature set and sometimes we are handling two or three sets simultaneously. We need multiple developers It is hard for every or few people to take on the various roles without help. So there are less people that can be a multitasker. So provides no written documentation to the client. We are not giving any documentation, although we are writing each and everything, but that is a rough sketching. So we cannot hand over sketching towards the customer. So the client is not able to get any proof of their or any documentation of their software, emphasizing individual code ownership instead of a shared team ownership. As the team member is doing work in little chunks, so a single person can do one feature at a time, so that will be a single user coding. If you are with where we can use that model, if you are within a big corporation or working on a large scale software project, it will be a suitable model for you. You may want to consider that methodology if your project grows too large and complex for the smaller scrum teams to efficiently handle the amount of work. This agile feature-driven methodology is well suited for long-term projects that continuously changing and adding features in the regular or predictable iteration. So in these situations, we can use that. Now, rapid application development model or AD model. In that model, we will uh, divide over project into different domains, and these different domains will be handed over to different teams. Like if our project has three domains, in that we will give that three domains to different three teams, and simultaneously they all these three teams will do that work at the same time, and in the last we will integrate their work, and that will be the actual software, and we will hand over that software towards our customer. So we will use that model for the speedily working, so it can made a large project in 60 to 90 days. So whenever we have less time, we can use that model. All the models almost have the same stages, like we have to understand the input, then we have to go towards the sketching, and then we go towards the construction phase, then we have to go towards the testing phase. But in that model we are using different teams, and we are assigning different domains to that teams. So there is a less attention paid to the planning and more priority is given to the development task, as we are only handing over our project to different teams, and we have to generate the project in last span of time, so in the less span of the time. So our target is the coding. We are focusing on the development phase, as we have to hand over our project quickly in the last. So we have to do these type of modeling: business modeling, data modeling, process modeling, application generation, and testing. These five stages will be observed and worked by all the teams that are working on different domains. Now we will discuss these phases. In business modeling, we will arrange a meeting in which we will collect all the information that is related to our project. That information can be gathered from many business related resources. We can generate or collect that information from different organizations and from different markets. So we have to collect a lot of information. This information is then combined into a useful description. So we will sort it out the important description or the information that is related to our project. So we will combine that information, or we will combine that data into useful information that will help out in the data collection and in the processing phase, and what is making this specific information successful for the industry. So we are collecting the information that is related to our project, and then we are making that information in a description form. Now we will go towards the data modeling. Now from that information, we have to collect which type of data is needed. So we said that we are going towards the data modeling. All the information gathered during the business modeling phase is analyzed. Now we will study all the information through analyzing the information is grouped into different groups that can be useful to the company. Now we will we are going towards the division of our work. The quality of each data group is carefully examined and given an accurate description. Now we are describing different modules. A relationship between these groups and their usefulness is defined in the business modeling step is also established during this phase of RAD model. Now we are defining different phases for our project. Process modeling. Now we are going towards we are making which things are we can say that what are the processes or what are the functions are needed in each domain. Now the process modeling phase is the step in RAD model produced where all groups of information gathered during the data modeling step are converted into the required usable information. Like we are converting our data into the processes, or we can say that into the functions. During the process modeling stage, changing and optimization can be done and the sets of data can be further defined. So we can decide what is the input, what is our processing stage, and what will be the output for each domain. Any description for adding, removing, or changing the data objects are also created during this phase. So we have to generate the final layout for our software. Now the application generation step is when all the information gathered is coded. Now we are going towards the coding as we have different teams and different teams are following all these steps and they are generating the each domain and in the last we will integrate their work. So we are going towards the coding and the system that is going to be used to create the prototype is built. For each and every domain, we are creating the prototype and for every step, we are updating that prototype. The data models created are turned into the actual prototype that can be tested in the next step. Now testing and turnover. Now in the last when we have generated the prototype, now we will test that and turnover stage allow reduce time in the overall testing of the prototypes created. Now we have to check or we have to minimize the errors or reduce the time of the testing. Every model is tested separately to identify and adopt the components quickly to create the most effective product because different teams are working on our project, so there are different model and we have to test the each model separately. Since most of the element have already been examined previously, there should not be any major problem. In the last, we only have to integrate all these models and make a single software from that. Now, what is the strength? As different teams are working on that, it will reduce the development time, increase the reusability of components as we have generated different models, so we can reuse that models for our other projects. It will quick initial review occur as we are handing over the different teams work towards our user so they can easily check that things. Encourage customer feedback as we have a lot of developers, a lot of teams to work, so we can get the feedback from the customer and we can facilitate our work customers. Now, what are the weak areas? It depends on the strong team and individual performance are identifying the business requirement. As all persons are doing their work individually and there are different teams, so their strategy might be different. Requires highly skilled developers and designers as we have to integrate all the work in the last. So we need skilled person that can work according to that model in effective way. Highly dependency on modeling skill. If their strategy is different and they don't know how to do the modeling, there might be the problems. Inapplicable to cheaper projects as cost of modeling and automated code generation is very high. As we need a lot of developers, so we have to pay to that developers and that team members, so it will sometimes increase the cost. Where we can use these models when we have to deliver the project very quickly. It is useful or it is the best model to choose when there are going to be changes made to the prototype throughout the process. Like we have to create the dummy model and then we have to update that dummy model. RAD should be used when there is need to create a system that can be modularized in 2 3 months of the time. As I told you, it will take 60 to 90 days. So we have to use that model where we have short time. It should be used if there is a high availability of designers for modeling and budget is high, as it is expensive. So we can use where there is no limitations for the budget and our budget is not tight, and we have skilled person inside our organization, so we can afford the cost and we can pay the cost. So we can create different automated tools, or we can use different automated tools. Now we will discuss the dynamic system development method. In that, we are also in the start, we will lay out or we will give a foundation towards our project. Like we have given a brief understanding at the start. So we at the start we have to check either there are the chances of success or not. So we will adopt that methodology. So the dynamic system development method is a technique that is associated to the degree agile code, that is based on the customer involvement, as we are giving a foundation and we are sure about the quality of the project and success of the project, so we must have to involve our customer. So that code development approach that provides a framework for building a maintaining system, like we are going to develop a system that there are the chances of success are high. So it is an iterative code method within which every iteration follows 80% rule, that simply enough work is needed for every increment to facilitate. We are not doing 20% of work or 30% of work. At every stage, we are doing the 80% of work from our project. So this dynamic model, so I can it can reflect the changes in the environment, because we are analyzing each and everything very quickly, and dynamic means it can be absorb the changes of the environment. Now, at the start, we will do the feasibility study. Feasibility study means we have to check either we have the team members, either we have the enough budget, we have the time schedule or not. So at the start, we have to check that we are able to complete that project or not, and that project will be beneficial for us or not. So it is essential business necessities and constraints related to applying to be designed the assesses whether or not the application should be viable candidate for the that method. We have to check that either that application can be designed by using that model or not. Now we will go towards the scope of that project. That is our business study. Why we are establishing or we are creating that project? What is the reason behind that? In which environment we have to use that project? Which are who are the users of that project? So we have to do the business study. We have to understanding the main core of that project. So it establish the use and knowledge necessities that may permit the applying to any business value. So we have to understand the business concept of that software. Additionally, it is essential application design and identifies the maintainability necessities for applying. So we have to check which things must be added day by day or after some time into that, and what is the necessaries or what are the needs of that project. Now the functional model, we have to create a model that is like a functional model. So it produce a collection of progressive prototypes that demonstrate particularly for a client. So we are not creating a schedule or 3D model or dummy model. We will create 80% of our project from that. As I told you in the start, we are not doing 20% or 30% of our project. We are making a functional model for our client. The intent throughout this unvarying cycle is to collect further necessities by producing feedback from the user as they exercise the model. As we are presenting 80% of our work in front of the user, so they can easily understand what either they are according to their demand or not, and they can give the feedback and we can make amendments in that. Then we will go towards the design and build iteration. It revits the prototypes design throughout useful model. Then we are converting that model into our useful model. iteration to make sure that everyone has been designed during a manner that may alter it to supply the operational business price for the finished user. So we are converting our prototype into the software. In some cases, useful model iteration and style and build iteration occur at the same time. Sometimes we are converting our model at and as well as the working functional model and the actual software at in the same stages. Now the implementation, it places the newest code increment into the operational surrounding. If we have to add any new things, if we have to make any amendments in that stage, we will go towards the amendment. It should be noted that the increment might not be 100% complete. Like sometimes we have to add different things incrementally, or after some time, or after some phases, we have to add the increment. Our changes are also requested because the increment is placed into the place. So as we are working incrementally, our different domains are added time to time. So according to that, we can make the changes in that. In either case, that development work continues by returning to the useful model iteration activity. We are also updating our prototype and our working models. Now, what are the plus points? The iterative approach ensures the basic software functionalities are delivered on time, as it also work on the quality as well as on the time. Developers have better control of the development timeline and the budget, as the developer has to decide how much time is needed and how much powerful they have to generate a prototype. So they have a decision power. Necessary documentation is created throughout the development, as in other modelings we have not generated the documentation, but in this methodology we are creating the documentation. It will establish communication between the end user and developer, as we are setting the meeting and we are getting the feedback after the prototype, which keeps the key team on the right track. What are the weak area? As when we are going towards the prototype, it quite be expensive. Smaller teams will have a hard time for the implementation, so that can be implemented for the large teams or in the big organization. The concept and implementation of model are quite complex. So actual model and the working model, to understand their difference is a complex thing. Now where we can use that, using the dynamic system model for small organization is out of question, as we need a lot of members to do that. Instead, it's better fit for the large organization. It breaks down rigid processes into smaller iterative parts and streamline communication between the different teams. So different team members are working on that and we are making the communication, so it will be easy to build our software according to that. Is there any problem? Have you any problem?
No, ma'am.
Okay, then take care. Have a nice day. Allah Hafiz.